Hello. So, I was thinking originally that my talk was going to be a little more controversial than that it turns out there's more people who are agreeing with this. 2 years ago, this was really controversial. But let's start out. My name is Paul Holland. I'm Senior Director of Test Engineering at Metadata, which is based in New York. We also have offices in London and Tokyo and San Francisco and a place that no one's ever heard of in New Jersey. As Jose said, I've been doing software testing for over 20 years. I'm not going to go through everything I did, but yes, I was a military helicopter pilot. I flew Canadian Sea King helicopters, which I stopped flying in 1995 because they were too old and falling apart, and they are still flying them. So it's only been 22 years. So people ask me if I miss flying, and the answer is no, because it's a lot less dangerous to go to work in New York and test than it was to get into a Sea King helicopter. I had a declared emergency roughly every 20 hours I was flying. Not just an emergency, a declared emergency, where I actually had to tell the air traffic controller that I had an emergency. So no, I don't miss that. And I haven't flown at all since 1995, May 18th, 1995. Anyway, so I did a practice session of this talk a few months ago, and somebody said, your title is misleading. You're not talking about all automation. You're referring to the UI or end-to-end type automation. So I added this slide into the talk so that it's clear that I'm not talking about all automation. I'm just talking primarily focused on automation that is written by testers, SDETs, software development engineers and test. I'm not talking about automation that's typically done by developers. I know that in some companies, developers don't write their own unit tests. Those are strange companies. And I'm also not talking about integration or API level automation, which, as it says, is typically written by anyone who's available who knows how to code. So, what automation will not do? That was kind of weird. Don't think I've ever had a trolley come up to me while I've been talking, taking a picture of a pink unicorn. So what automation will not do, likely not do for you? It will not increase your coverage. It will not, they're doing it again. It will not decrease your costs. It will not save you time. It will not allow you to reduce headcount, unless you also increase risk by doing so. So most companies that don't understand what automation can give you will assume that they're going to get these types of savings or these types of benefits from performing a lot of automation. I worked at Alcatel-Lucent for about 17 years, and the head of my business unit's development team, so he was a senior vice president, and he said, our goal is 100% automation. And he was based in Belgium, in Antwerp, and I was based in Ottawa, Canada. And about 2 months later, I was in Antwerp, and so I went into his office, and I closed the door, and I said, Henrik, what were you thinking when you sent out that email? Do you know how much time has been wasted by people trying to automate everything because you said our goal is 100% automation? People have spent days and days and days automating something that only would take 5 minutes for someone to test manually. And he said, well, that wasn't my intention. My intention was to automate what makes sense. Then why did you say our goal is 100% automation? They're slightly different messages. So, what automation can give you? It can give you a decent sanity check of your product. And yes, you can have a lot of automation and you'll get a better sanity check of your product than you would if you had just a little bit, but it's not ever going to do in-depth testing. There are some caveats to that, which I'm not going to get into. But for the most part, it's not going to give you anything beyond a sanity check of your product. And it will also let you execute in less time than a human performing the same checks. So, Nortel Networks was Canada's largest high-tech employer. It is no longer anything, let alone an employer of anybody. They managed to manage that company right into bankruptcy. But I had a friend there who was a director of system testing of one of their products. And she had 1,260 bugs that were raised by, this wasn't automation, but this was by scripts, so humans executing scripted testing. And she asked for an analysis of those 1,260 bugs to see how many were found by the script and how many were found by a vigilant tester. So essentially in their ticketing system, they would attribute that while they were executing a script, they had found this bug. So 1,260 were found while the tester was executing a script. But the director had a suspicion that many of them weren't found by the script itself, but by a vigilant tester who noticed something outside of the script. So the script said, do action A and look for B. If B wasn't there, then that would be attributed to the script. But if B was there, but something else had gone wrong, then it would be attributed to a vigilant tester. So what her findings were after going through all of the bugs was that 70% of the bugs were found by a vigilant tester, not by the script itself, which has quite a few ramifications to me. The first is, if you're outsourcing your test execution to a third party that doesn't know your product, they are not going to find anywhere near as many bugs as if you outsource your execution to somebody who does understand your product. Only 30% of the bugs would have been found if these were automated as well, because automation will only check what you ask it to check. It's not going to notice something that it's not programmed to. And so as a result, had this friend of mine had automated all of these scripts that her team was executing, they would have only found 30% of the bugs that they found over that year. So, why did I call my talk the pothole of automating too much? Well, if we think of your software as the United States of America, and your features are the cities in the country, and the paths from city to city are the routes that your customers can take through your software, okay? So here's a map of the United States of America from 1907, so we'll call this release 1 of the product. And there's some future areas, like some states, like North Dakota and, where's that, Arkansas? Don't have any roads at all, because those are future features for the product coming. And to be honest, no one still lives in North Dakota. But so somebody might look at this map and say, we can automate these paths. There aren't very many of them. Look at that. Let's have a goal of trying to automate everything here. And so some automation is written that covers a lot of these paths, and everyone is happy. And then time progresses, and the product gets slightly more complicated. And then we're looking at this, and we're saying, wow, that's a lot more automation we need, but it's still pretty manageable. But the big problem is these are just the highways. These aren't all the paths that your customers can take through your code. there's way, way, way more roads, way more different options, way more different things that your customers are going to do than you can possibly start to try to automate. So as an example, using Google Maps here, if we look at Denver in Colorado, it only has 5 roads going into it. But if we zoom in, we'll see, okay, well, there's a little bit more than 5 roads, but again, that's still possible. But then when you zoom in a lot more, and this isn't even the furthest I could zoom in, we start to see that, hey, when I'm in the featured Denver, there's a lot of different places that I can go. And if I write automation for all of those, the automation would take longer to execute than it would take for my company to go bankrupt. So I did some consulting work for a large American insurance company. And one of the things that I did was to look at the automation that they had created. So they had a lot of automation. And they had decided to write an automated check for every single written requirement that they had. Why would they have done this? Well, here's some thoughts that maybe they wanted to catch more bugs. They wanted to increase their coverage, they wanted to future-proof the product, show thoroughness, or reduce the headcount of their manual testers. Or maybe they just wanted to make their management feel better. My guess is probably all of these things were thought of as to why they decided to write all of this automation. But when I started to investigate the automation that they had written, it wasn't, they initially thought that it would do all that. When I started to look at their automation, because their automation wasn't being effective, and I'll tell you how effective it was in a second. So I looked at the automation itself, and I have quite a bit of experience in automation. I started out at my career as an automation developer, and then I was an automation development manager for a few years, and then I realized that I could probably be a little more effective if I was looking for bugs instead of trying to show the software worked. So I am pretty comfortable and knowledgeable of good automation environments. And I noticed that the automation environment that this large insurance company had was truly one of the best environments that I'd seen. It was homegrown. They had an excellent framework that it was very modular. They dereferenced all of their calls to the system, so if how you log in changed, they'd only have to make the one change. They didn't have to change all of their scripts. They'd actually even included variations based on release. So if you passed in the release number, you could handle 2 different types of logins. It was a really, really good system. They had written over 2,500 scripts, which is a number that should mean nothing to any of you, because how complicated are these scripts? Are they 1 or 2 lines? Or do they take 24 hours to run? Counting scripts is as useless as counting test cases, but I just wanted to throw up the number of how many separate scripts they had. It was 2,500. They tested all the written requirements. Of course, that's not all the requirements. That's just all the written ones. They actually had a very bizarre mentality there, which was if they found a bug, by any means, that didn't contradict a written requirement, they first had to raise an enhancement report to get a requirement created, and then they could raise a bug against that requirement. I am not making this up. And it's a successful American insurance company. So, when I analyzed their testing situation, they had 13 outsourced testers in India who took 2 weeks to execute the 2,500 scripts once. So every month, they would execute the 2,500 scripts twice, 13 people. So every month, they were 1 person year plus 1 of testing effort. 40% of the scripts failed on each execution. Remember, their framework was good. And it was good. I didn't bother analyzing why the individual scripts were failing, but apparently they had flaky network connections and things like that, bad timeout decisions. So they would re-execute them. If they passed, then everything was fine, because that's never a problem. And if they still failed, then they would have to investigate why they failed. So that's why it took them 2 weeks to execute the 2,500 scripts. Roughly 1,000 would fail each time that they executed them, and then they re-executed them, and they still had a few hundred that they had to go through to figure out why they were failing. And this team that was doing 1 person year plus a month of effort every month found in a huge amount of bugs, on average 6 defects a month. So I asked a test lead there, I said, do you have half an hour? Let's sit down and do some pair testing. And so we did, and in 20 minutes, we found 5 bugs. So there was a little bit of difference, even if we assume that 20 minutes was a half hour, and there was 2 of us, that's 1 person hour of effort. We found 5 bugs, and in 13 person months of effort, they were finding an average of 6. So I think the manual exploration was being a little more beneficial. When I gave them my recommendations, because I gave them a booklet on recommendations, and the first recommendation, which they did not heed, was to throw away 2,500 scripts and write roughly 100 or so that would give them a nice end-to-end test in a little bit more robust method, and stop trying to test all their business logic up at the GUI level. But I gave them, I can't remember, it was 12 or so recommendations, and the only one to my knowledge that they didn't follow was that one. Anyway, so some of the problems with automation. There's more kinds of problems than automation can be programmed to recognize. You would need to be able to predict every single problem that your software might come across and anticipate it, and then program your automation to look for that bug to be able to have automation recognize all the bugs. So if we go back to the analogy of the car driving along the road, we have an automated drone and it's going along the road from one city to another, and it's looking for potholes because our customers don't like potholes. So it's looking for potholes, and then it sees an oil slick. Is that a pothole? It's dark, it's not reflective, it could be a hole, I'm not sure. I'm going to report an oil slick. Or it drives along and there's a missing barricade beside a bridge. It's not programmed to look for that. Or the road signs are wrong, or the speed limit signs are wrong, or there's a stalled car on the side of the road that's been there for 2 releases and no one's noticed it yet. These are things that you would need to be able to predict before you sent the drone along the road to be able to know if your software was working properly. So vigilant testers can observe and evaluate a very large variety of outputs, and also vary the inputs so that they're exercising different roads and not just spending the whole time on the highway. So a friend of mine, Martin Nilsson, told me an interesting story. He was at a customer site and they were doing an update to a web page, and they sent the updated web page to their customer, and immediately the customer called back and asked them if this was some kind of joke. And Martin wasn't sure why. It was a rush job, and they'd run the automation, and the automation had 100% pass, so they said, okay, there you go. Our fix must have worked. And then a human looked at their web page, or tried to, and it wasn't there. Their entire web page rendered in a single pixel. So without a human looking at it, the automation said, oh yeah, here's the label. I'm going to fill in that value and hit return because I know where those things are because I'm not looking at what a human would look at. And as soon as a human looked at it, they went, there's nothing here. It's completely blank. So the automation wasn't programmed to look at anything visual. It was just programmed to see if simulating that a user would type in this here and carry on. So without being able to predict all of the bugs in advance, automation is going to miss them. There are more checks to write or to automate than can possibly be written. Going back to our picture of Denver, we would not want to try to automate every combination of every path just through the city of the city of Denver, because that's not our only feature, and even if it was, we wouldn't want to do that. Now, doing that at a unit test level, maybe not every path, but doing a lot of paths through the unit test level makes some sort of sense, but trying to have end-to-end automation beyond can our software work just gets cumbersome. There are some things that are just too difficult to automate. And yes, software is getting better, and there's lots of really cool tools coming along like Sakuli, which lets you do a visual representation. As long as it's 80% visually like this one, then we're going to say it's fine. That's great. But still, even though the tools are improving, there are still lots of things that are too difficult to automate. We have complex pass-fail algorithms. When I was at Alcatel-Lucent, we had some automated assisted testing that we did, where the automation would have the product do a lot of work for us, gather a lot of data, and then save an Excel spreadsheet for us. So when we came in the morning, we would look at the graph in the Excel spreadsheet, and within seconds, a human could say, that's passed or that failed, but to write the algorithm to do that would have taken weeks or months, and it probably still would have been wrong. So sometimes humans can actually outperform even on big things that need to be done, but you can have the automation help you. And this is the one that killed the insurance company I work for. Investigating reported failures takes a long time. And that's one of the biggest costs of automation. If you write automation and you write a lot of automation, you're going to get a lot of failures, especially at the GUI level, because they're fragile. And they break when code changes. And every one of the failures needs to be investigated. And think about this. If you have failures that they're not investigating, why are you executing those tests? It is a complete waste of time. If there's a test that is executed that if it fails, nobody fixes it, delete the test. If they don't care that there's a failing test enough to fix it, then there's no point in running it. So just keep that in mind. And the last point I have is automation is expensive to build and maintain. The insurance company had a team of 13 people just executing, not even writing and fixing, but just executing the test, because the more automation you write, the more maintenance you have on it, and there ends up being a high cost to value ratio. Automation will not find the bugs for you. It shows that your software is working when it does that one thing, but it doesn't necessarily find bugs for you. It'll find bugs if they're planted in the path. So if somebody, I sent a drone on the road from Denver to Colorado Springs, and it made it their last release, and this release it disappeared halfway through into a massive pothole because someone planted a pothole on that road. It will find that, but it's not going to find bugs that it already missed. And the sunk cost syndrome, this is what killed the insurance company. They had invested many, many person years of effort in their automation, and they weren't willing to just get rid of it. They kept it going. So what can you do about this? Well, I like to consider a strategic mixed approach. So I'm not saying don't do automation. I'm definitely not saying that. Unit level and API level tests. Unit level tests to check that the code is working at a tiny piece level. API level testing to see if your business logic is working. Those are fine. And some end-to-end tests to show that the GUI level and what a user is going to experience works. But only the critical paths. If you're automating more than that, you're likely going to pass the benefit of the cost to benefit ratio. Automating paths with the highest usage. So if you know that the vast majority of your users just use the default values, then automate the default values. That would be the highest use. Do not write automation for all the failures you found in the field, at least not at the GUI level. One other company I worked for had a rule that if a customer ever reported a bug, we needed an end-to-end test that would test that bug never came back. friend of mine, James Bach, had an interesting analogy on that one. It's, if I owned a zoo and there was faulty gates on some of the cages, and let's say the polar bears discovered that their gate was faulty, so they opened the gate and the polar bears escaped. And now the zoo owner says, make sure you check that that gate is properly closed every day when you do your rounds. Essentially, instead of looking for other faulty gates, what you're doing is you're spending time making sure that the polar bears who already escaped couldn't escape again, while the other animals that are still in their cages that haven't found the faulty gates, instead of looking for those faulty gates, you're continuously spending time looking for things that you've already fixed. Unless you have a really bad configuration management system and you tend to reintroduce bugs, which some companies do, then that would be a different story. Considering the cost of automation versus the benefit, you don't want to be automating everything because the senior VP said our goal is 100% automation. You want to consider how difficult is this automation to create, to maintain it, how often is it going to be changing. Make sure you modularize your code, dereferencing calls. You don't want to be calling your product directly. You want to have an intermediate layer so that if there are changes to the product, you only have to change it in the one spot. And how hard is it to analyze the failures? Ask for testability in the code from your developers. It will help speed up your development. Augment the automation by testing by actual humans. Us, people. We're way better at testing than software will be, for the most part. There are some things that automation can do better, but for the most part, humans are better at it. So the point, and I've mentioned this already, automation is an excellent way of showing that the software can work, but it takes a human to show how it might not work and how it might fail in ways that are important to your customers and to your stakeholders. And as Angie Jones said yesterday, she's an automation developer and she will not be able to automate away the job of a tester. So the job of a tester to go in and find bugs is still going to be the way that we find bugs for the foreseeable future. I've seen people talking about, well, there's machine learning. Okay, great. That is now a very complicated piece of software that you're trying to have replace a human instead of just having a human do it. I'm not saying it's not possible to happen, but I don't see it happening while I'm still working. I know I have gray hair, but I'm going to be working for a while. All right, and then finally, always be yourself, unless you can be a unicorn. Then always be a unicorn. Thank you.
Thanks so much. Questions? Guys? Any questions? Okay. Yeah, there.
Way at the back over there.
In the back, yeah.
Okay, next question needs to come from up front over here.
May I? Yeah, I took breakfast today.
Yeah, I agree with most of this.
Take the
thoughts
mic.
I had, like this?
Yes.
Ah, there we are. Yeah. Some of the problems you mentioned here seem to be inherent to automating at the GUI level, and others of them seem to be to do with bad tooling and bad process.
Yep.
So I react to a lot of this by saying, we clearly need to be doing this in a better way. Do you have any thoughts on that?
No, I agree, and I thought I mentioned that tooling is getting better in solving some of these problems as we go, but the underlying premise of automation will still only be showing that your code works, not finding new bugs for you, is sort of where I was going. So once the automation passes, you can run it 800 times and it's going to pass 800 times. And if it isn't, then there's something wrong anyway. But if you have a tester go and test something 800 times, they would likely continue to find bugs because they're going to be varying how they do it, hopefully. If not, then they should really take some courses on exploratory testing.
Okay.
Really?
Really?
Oh, if I thought correctly, you are mentioned as about something that you need to create a strategy for automation, like based in risk, business risk or something like that. You regression tests or something that you can work with automation, and then you can need to create a project to automation, like analyze strategy, and then you create something that's really important for the product. That's right?
Yep. Yeah, so primarily focusing on the critical paths, the paths of highest frequency. Using GUI level automation to try to automate corner cases or unlikely events that aren't probably going to happen, but if they did, it would be potentially catastrophic. Having those automated, unless there's a business reason to do so, like, oh, well, we know if this particular bug happened to propagate itself, then it would cause database corruption. Okay, well, that's an important enough one to probably to automate. But the wrong error message might pop up for a user. Who cares? Oh no, the user had a slightly bad user experience. It could be important, but it's not going to be important enough to write and maintain a script for years on the unlikely event that event's going to happen. So yeah, having a strategy, identifying what do we need to automate to show that the code works, and then using testers to explore the product to essentially look for more of the corner cases and see the problems that the users might see when they're using the product. But yeah, having a strategy and thinking about it up front. What paths do we need to show work so our definition of done is going to be fulfilled? So if you're doing BDD development, what feature files are you going to want? What are you going to automate? What are the feature files that need automating so we can say, there, it works, we're done, as opposed to what other testing do we need to do to say that we've done a reasonable job of covering off our risks.
Hi, thank you for your talk. I totally find, I think your story is the way we should go on. The only feeling I have, how do we combine this story with the continuous delivery stories of other, like Jess Humble having the first keynote, and he was saying, okay, we have this first stage testing, second stage testing, and in the end, if all the, in your case, sanity checks are done, we can put it into production. Mm-hmm. It's more API testing, of course, as well, which is involved, which is great. But how do we, you say we always need a manual step there somewhere. How do we combine these things?
No, I said you augment it with manual. So that's a good point. If you're in a continuous deployment or continuous integration scenario, you'll need a better infrastructure of unit tests and API tests, and perhaps a larger number of end-to-end tests as well. But remember, the point of these tests is to show the software can work. So if the software is shown to be working, you can deploy it. The point of augmenting it with a tester during development, before you get to the commit phase, the software should have been tested as well. So either pair testing with the developer or just developers and testers working together. And once the code is committed, it should have already been tested by a manual tester, and then or tested by a tester. Manual testing. Let's not go there. Manual coding. So it should have already been tested, and then the commit is a sanity check to say, yes, it still works. So yeah, the strategy still works with that environment.
Great, thank you.
More questions?
Only this side has questions.
Yes, or with the right part. Thanks so much, Paul. So, this for you.
Thank you.
Thanks so much.